Chemical reactions. Chemical reactions are what keep chemists in business because we make new compounds and molecules. We make new substances when we conduct chemical reactions. So, chemical reactions are what we described back in chapter two as chemical changes. And you are making new substances. Now, by new substances, we mean new compounds, new molecules, but not new atoms. Okay. So compounds, molecules, etc., but no new atoms. That's impossible. So we can't take copper and turn it into gold via by using chemical means. So this is what we mean by a chemical reaction. Reactions are we use a representation, and that representation is called chemical equations for the chemical reactions. And what they do is they identify reactants and products, and reactants are on the left side of the equation, and products are on the right side of the equation. So a chemical equation looks like this. We don't use an equal sign, we use an arrow that tells us these two reacted together and they made these products. So there's one thing that's very critical that you pay attention to here is that the numbers of each type of atom on both sides of the equation are equal, and we need to balance the equation. We'll get to this in the next video, but this is really, really important. If we start with one carbon atom, we have to end with one carbon atom on the other side. If we start with four hydrogen atoms, we must end with four hydrogen atoms. You can't just matter. Remember, this is against the law of conservation of mass, which means whatever you start with, you must end with the same exact amount. So in this case, if you notice, we will get to this again a little bit later, but you have one carbon atom and you have one on the other side, four hydrogen atoms, four on the other side because it's two times two. And then you have four oxygen atoms and four on the other side, where they come from here, from the carbon dioxide and water. Look at these. So a very simple chemical reaction is really just turning on the stove, right? When you would like to boil water or heat something. And what happens is that you are really combusting methane, which is natural gas, with oxygen. And this produces carbon dioxide, water, and of course, most importantly, is we need this, we need heat. There are physical states, right? Phases of reactants and products, and they are in these parentheses right here, in the subscripts and parentheses. So if you have G, that's gas. If you have L, that's liquid. S is solid, and AQ is aqueous or aqueous, which means it's dissolved in water, right? It's like salt water versus salt. So if you have something like this, this is solid, right? Table salt. But if you have this, that's salt water. So there's a difference between these two. There are many signs of chemical reactions. We will get to them, but this picture actually represents the signs of reaction. So again, you have a solid forming, you have a smoke, you have changes in temperature, pH changes, whatever. All of these are signs of the reaction. One more thing before we get to the signs of the chemical reaction is the coefficient and the subscript. So what's the difference between the coefficient and the subscript? So the coefficient is really at the front of a number. So if we have in the equation H2O, we have a 2 in front of it, That is what we call a coefficient. But a subscript is this right there. There's a difference between them. A coefficient indicates the amount of substance. So if I have 2H2O, as I show you here, that means you have two water molecules. Here they are. But in H2O, the subscript indicates that water must be composed of two hydrogen atoms and one oxygen atom. So in this case, you see two hydrogen atoms and one oxygen atom. You cannot change the subscripts. If you change the subscripts, you change the entire compound. So if I have H2O, I put a subscript after the O, it becomes H2O2, which is hydrogen peroxide. And there's a nice cartoon about this, and I hope you understand it. That just warns you, right? Do not change the subscripts. So I hope you get this one. It's kind of funny. That's all we have in chemistry.